Hey everyone, and welcome to today's Explainer. I am so pumped you're here. Today we're unpacking a radically innovative approach to the future of work and vocational training. We've set out to make a highly detailed, complete explainer about the three-buddy system, diving deep into how humans, humanoid robots, and advanced AI vehicles are teaming up to completely reshape how we learn on the job. If you love seeing how complex technical systems create real-world social impact, well, you're absolutely in for a treat. But first, I want you to picture something. Think about your very first week at a new job. Usually, you're paired up with a senior employee to kind of show you the ropes, right? Well, what if your next workplace mentor, the one coaching you through complex daily tasks, wasn't human at all? What if you were learning right alongside a humanoid robot? It totally challenges everything we know about onboarding. And the crazy thing is, it's happening right now. Okay, let's dive into this. You might already know the traditional HR three-buddy system used by companies like Buffer. You have a hiring manager for supervision, a role buddy for specific job questions, and a culture buddy to help you navigate the organizational norms. But over at the IHK Fasanenstrasse Fast 100 pilot project, they've evolved this into a robotic three-buddy system. You've got a human supervisor, a humanoid AI called Fastbot acting as your peer buddy, and a self-drive AI Rickshaw as your actual working environment. Wild, right? So here's our quick roadmap for today. We're going to cover 1. The VET 4.0 challenge, 2. The triadic architecture, 3. The three buddies, 4. The co-learning loop, 5. Ethical control, and finally 6. Social impact. All right, kicking things off with Section 1, the VET 4.0 challenge and the triadic architecture. To tackle this whole challenge of securing skilled labor in a digital world, the Fast 100 project relies on a foundational philosophy called the triple layer concept. Instead of just a human and a machine figuring it out, we have 3 synchronized layers. First up is autonomy, handled by the AI rickshaw. Second is assistance, provided by the Fastbot humanoid, which acts as a social catalyst. And third is ethical control, securely maintained by the human supervisor. By splitting the cognitive load up this way, the whole system becomes highly efficient and, absolutely crucially, incredibly safe. Moving right along to Section 2, let's officially meet these 3 buddies. Buddy number 1 is the self-drive AI rickshaw. And look, this isn't just a vehicle. Actually, scratch that. It's really more like a rolling data center. It uses V2V, or vehicle-to-vehicle communication, to process raw telemetry context in real time. But what's really brilliant here is its health and usage monitoring system, or HUMS. It constantly monitors its own electrical and mechanical vitals to estimate the remaining useful life of its parts. It even maintains a digital twin, which is basically a virtual replica of itself, to simulate wear and tear, so maintenance becomes predictive, not just reactive. Pretty smart. Then we have buddy number 2, the Fastbot. Now, what's super interesting here is how they define Fastbot's role. It isn't just a mechanical tool, it's explicitly designed to be a social catalyst. By using anthropomorphic traits, acting more human-like, it deliberately lowers the psychological barrier to engaging with complex tech. Think about it. If you ask a human expert a really basic question, you might feel a little embarrassed. But Fastbot, it provides a completely safe space for stupid questions. It acts as a non-judgmental peer buddy, giving trainees the confidence to experiment and learn without all that anxiety. It's fascinating to see how the human response actually evolves as the robot's capabilities scale up. At the trivial level, the human pretty much just treats the robot as a reactive object, kind of like a fancy toaster. But as we move down to social and temporal interactions, the human begins to recognize intent and synchronize timing. It's kind of like a collaborative dance. Finally, at the pedagogical level, the system hits true co-learning. The human and the robot engage in behavior shaping, treating each other as genuine teaching partners through imitation and reinforcement. And this brilliantly sets up the role of buddy number 3, the human supervisor. The supervisor is the ultimate ethical authority here, relying on the human-AI interaction, or HAII triangle. This triangle has 3 pillars: usability, understandability, and trust. The human absolutely must properly calibrate their trust. Miscalibrated trust is super dangerous. Overtrusting means you might blindly accept a machine error, while undertrusting means you completely ignore valuable AI guidance. So, the supervisor constantly uses this framework to maintain perfect operational oversight. Next up, Section 3, the co-learning loop. This is where the magic happens in real time. To build the underlying intelligence of this whole system, they use a classic reinforcement learning loop. In the three-buddy system, the robotic agents aren't just running pre-programmed static scripts. They take actions, observe their environment, and then receive rewards or corrections based on human feedback. This continuous loop allows the humanoid and the vehicle to constantly adapt and refine their operational policies based on what the human supervisor dictates is good or bad behavior. So here's how this bidirectional co-learning loop actually plays out step by step. Step 1, the human teaches the fastbot a practical task, like a pre-flight safety check through imitation learning. Step 2, the fastbot turns right around and coaches the human on safety in operation, giving real-time hints. Step 3, the rickshaw is constantly feeding raw operational telemetry into the loop to give context. And Step 4, iterative correction. The human evaluates and corrects the system, the robot updates its routine, the vehicle adjusts its driving, and the cycle just repeats. Everyone is literally learning from everyone else. All right, Section 4, ethical control, trust, and oversight. Now, to prevent any catastrophic failures when humans and heavy machinery mix, the system uses Bayesian inference for something called influence-aware safe control. Basically, safety isn't just mashing a big red stop button. The system actively infers what the human is trying to do, their underlying goal, and the robot intentionally influences the human's behavior to guide them away from physical danger. The AI is literally calculating how its own actions will change the human's next move, actively steering the entire human-robot team toward a safe outcome. It's a real game changer. And finally, Section 5, social impact and social inclusion. You know, the local IHK FAS 100 project maps directly onto the United Nations Global Sustainable Development Goals. This whole elaborate technical apparatus is built to pursue inclusive education, decent work, and economic growth. Specifically, it targets NEET youth. That's young people not in education, employment, or training. The big goal here is to bring marginalized groups right into the digital revolution, ensuring that high-tech vocational training isn't just reserved for the elite. To actually make that happen, they built an incredible framework of socio-psychological support right alongside the technology. There's a super low barrier entry. You literally don't even need a CV to join. They provide stipends and travel aid. They integrate part-time social workers, peer mentoring from past cohorts, and blended learning touchpoints. The technology is completely enveloped in this social scaffolding, which helps trainees bridge the digital divide and gain highly technical skills without the crippling anxiety you might find at a traditional classroom. The ultimate vision of the three-buddy system is beautifully summarized in the project's synthesis. It states, "The future of work is one where humans and machines thrive together in a coordinated, safe, and socially productive ecosystem." It's just this brilliant fusion of cutting-edge AI, autonomous mobility, and deeply empathetic, inclusive pedagogy. Which leaves us with this final thought for today. As humanoid robots transition from being mere tools to becoming our mentors, our non-judgmental peers, and our co-learners, how will your own role evolve? When you're working in the triadic ecosystems of tomorrow, what unique human value are you going to bring to your robotic buddies? Definitely something to think about as you go about your day. Thank you so much for joining me for this explainer, and as always, keep learning.